in a corporate environment, it was hot garbage. Hot garbage.
I was just gonna say that was like that. Just everyone to let everyone know that we are streaming this. So if you just yeah. Anyway, yes, Ubiquity. I know that BW hates them. I like them, but I haven't been burnt by them yet. I don't have their firewalls, by the way. I don't think their firewalls are that
Mm,
good. But
yeah.
the switching, like the unifier in the thing, is what I wanted, but because I didn't want to have to config T. But I could be proven wrong. I know that there's a whole bunch of other stuff out there that's equally as good. I'm just going to maximize the screen. So I'm just going to quickly formally kick it off. Get everybody. Welcome to tonight's meetup. I'm your host, Michael. I'm going to use the loose term facilitator. I don't like the word leader. I don't really lead much. I just kind of facilitate. Let's do a quick, before I do anything, just a quick audio check. Okay, cool. Yeah, we're good. Alrighty. I'm just going to quickly throw some slides up and then I'll hand it over to our esteemed AWS guests. And then we can talk about LAN parties. No. Just 2 secs. I'm just going to quickly get the chat open.
Actually,
With regards to chat, what I'll do is any chat that's posted in Teams or in the in Twitch chat, I'll just kind of throw my hand up and relay. So anyway, we'll quickly kick it off. Just got some slides here. Hopefully that. Oh, that's the wrong side because. And that actually reminded me, I have to actually share my screen this time. There we go. Cool. Just let me go ahead and share my screen. Whoops. Nope. Nope. Not that. Let me just share my screen. Just make sure. Let me know if you can see my screen.
yep.
Cool.
At
All
least
right.
I can.
Oh, you can't see slides.
No, I can. All good.
Okay, cool beans. All right. Yeah, like I said, thank you everyone for joining. The Brisbane Infrastructure DevOps User Group is sponsored by ScriptRunner and Hudson. ScriptRunner is a little bit of background to ScriptRunner if you're not familiar. ScriptRunner is a really great tool that if you want to run PowerShell in an environment that you want to abstract away the complexity of running PowerShell, think ScriptRunner. So it's really good for giving simple scripts to help desk staff and things like that, where you want to do some sort of basic automation. It can do also very complex automation. Supports really cool things under the hood. It features a lot of query-based parameters and things like that. So those kinds of that interface that gets presented to your end user is as basic as you want it to be. So yeah, think ScriptRunner for PowerShell. With regards to recruitment, our best friends since from the beginning, our guys over at Hudson Recruiting. I've known Pablo for many years before this, and he was one of the original sponsors getting on board with it. So yeah, huge thank you to our sponsors at Hudson. They were providing basically providing an awesome space for us, and having an amazing environment, and you'd be able for us to meet in. So, alrighty, let's go quickly go through some news. I'm going to talk a little bit of things about what's going to be happening with the Meetup group, and yeah, so. There's not really much in terms of news in terms of the Azure environment. I couldn't really see. Obviously, build was out last month, so there was a whole bunch of new stuff that was introduced in the stack. From the PowerShell side, it's fairly quiet. I did dig up some interesting stuff, which I'm still surprised it hasn't been fully resolved, which is Travis CI. So if you're not familiar, Travis CI was one of the original workers for GitHub before GitHub Actions became a thing. It's not really recommended to use Travis anymore. Someone else could probably comment a little bit more about it, but I know that with GitHub, they essentially just say use GitHub Actions for your CI, and this really just comes down to security. There's been a fair few leaks with regards to security tokens and secrets being leaked. And then just something else, so just kind of a little fun thing there is GitHub's going to be deprecating the Atom IDE. So if you're using the IDE, which I don't know if anyone really is. Most people are generally using VS Code now. So yeah. Alrighty. I think, and then the next thing I quickly want to talk about is on Slack. I'm just going to quickly end the show. Sorry, 2 secs. Cool. I'm just going to stop sharing. Actually, no, I'm going to reshare. Sorry. In the general chat, we're really needing feedback for the user group with regards to finding a future direction for it. So myself, Alex, and Mitch sat down. We kind of had a bit of a discussion about where we want the group to go forward. What the idea was that we're really struggling to find speakers. So that speakers internally within the group as well as externally. And essentially what we're wanting to do is essentially structure the user group to be a lot more informal around, a little bit more, more of a based on a podcast, so people can still reach out and approach us if they want to present a topic, and we can kind of structure the topic around that. We, can keep it still fairly flexible, but that's kind of the idea that we're wanting to do. We still want to keep the same regular cadence, just so that we can kind of still, whether it's formally or informally, we can still catch up and talk about IT life, whether it's troubleshooting problems, and kind of have a whether it's an informal hackathon, or and just having informal talks about some specific tech within of expertise, or a bit of a show and tell. So yes, if we really would like to see some feedback with regards to that future, where that direction we want to take the user group. I know it just really depends on what everyone's kind of wanting, and how we can kind of make that happen. So with that ado, I don't think there's really anything else to mention. So I'm just quickly go back to the slides. Yep. So the next slide is our keynotes. So I'm going to hand it over to our esteemed speakers from AWS. Seb and Carlos. Hang on 2 secs. I'm just going to stop sharing.
Thanks, and I'll take over a screen share. All right, let me just configure a few things on my end here and put this into presentation mode. Is that coming through fine?
Yep, that looks good.
All right, are we good to start then?
Yep.
Cool. Well, hi everyone. My name is Seb, and I'm here together with Carlos, and we are solution architects at AWS. And effectively, as our day jobs, we help customers implement good DevOps practices on AWS cloud. And today we want to talk to you about what modern DevOps on AWS looks like. By the end of this presentation, we hope that you will learn how to increase agility, security, and velocity within whatever is the thing you're working on today, and especially if it's something that's running on AWS. Out of curiosity, what's the general knowledge levels of AWS within people on teams?
So I'll go first. I used AWS in 2017. That was probably the last time I've touched it. From that's just been Azure. So.
Okay.
For me, I used AWS for about a year in about 2020, and but other than that, I'm usually Azure based. So it was good to get some exposure on a different cloud then.
Okay, cool. We will keep this focused on obviously on DevOps. We've got a bit of a concept app we'll move into in a moment. So we'll talk about a few specific tools and services. We'll try to go easy and explain them, but then obviously there will be plenty of time for questions at the end as well. But let's kick this off with the presentation we prepared for today. And for the context of what we want to talk about today, we've prepared this company that we're calling FryMeUp. And FryMeUp is the #1 producer of air fryers in Australia and New Zealand. They have just released a new model. It is internet connected. It's got this groundbreaking chicken frying algorithm that simply makes the best chicken in all of Australia. And they effectively the brand new model with heavy marketing. It's been selling really well in Australia, and it's obviously running on AWS. And FryMeUp has built their frying app that goes together with the air fryer. They've built it using modern architecture on AWS. So for those of you that maybe used AWS a little bit, what you're seeing here is a typical architecture of what a serverless app looks like, especially the backend element of it. For those of you that haven't, I will just very quickly explain what we're looking at. We're effectively looking, obviously, at the air fryer, which is how the users are interacting with the device through the nice, shiny, big LCD screen on the air fryer. That then interacts with the backend application that's hosted through CloudFront, which is a content distribution network. S3 is effectively a place to drop your objects that can be served through CloudFront. And then the backend application, which is API gateway, which is effectively an endpoint against our REST API calls with a Lambda functions. That is a serverless way of executing code. Together with our data layer being stored in a NoSQL database, which in AWS world is called DynamoDB. And as you can see, the FryMeUp has built their frying app using this modern architecture, using these modern architectural principles. It's all fresh, it's all shiny, and it should be running well. But we have a problem. The customers are complaining that they can't fry the chicken and that it's burning. And obviously our CEO, she's also got this air frying, being a big fan and believer in this company. And her chicken, she tried frying the chicken last night and it burned. And she's sending a message to her team and to the managers, asking to drop everything. My air fryer burned my chicken last night. Now I understand what our customers are complaining about. This is your top priority. You need to solve it. But why is this problem happening? FryMeUp has built this chicken frying application using all these modern practices. So why are they still having these problems? And potentially the reason for which they're still having problems is while they've thought about a lot of things when it comes to the concept of building the application, they have not considered some of the run aspects or the operational aspects of their new application, their new air fryer, something we also call DevOps. And these are some of the challenges FryMeUp might be facing. Are they producing a good or better quality software? And are they delivering their updates and the software delivery? Is it done in fastly and timely fashion as the customers expect today? Do they have the right culture of continuous improvement? And do they have a architecture design that's correctly validated with appropriate implementation roadmap? These are the typical challenges the customers like FryMeUp are facing with correct implementation of DevOps. And there is a solution to this. And the solution is, well, effectively, do your run aspect properly and consider all these problems you may be having. And what we mean by DevOps, we focus effectively on these principles that are derived from the AWS DevOps white paper. So things like they probably very familiar things to you, at least most of these things on the screen, CI, CD, infrastructure as code, observability, security, as well as the communication, collaboration, the business continuity planning. So what we're going to do over the next few slides, we're going to look at how FryMeUp implemented some of these key practices in order to improve their air fryer and prevent the chicken from getting burnt. So over to you, Carlos.
Thanks, Ed. So one of the first things that FryMeUp looked at was it took really long for them to build their code and to actually be able to deploy it. When they got down to the root cause, they discovered that they had these really long feature branches. and or a branch per environment. What that meant was that they had these big problems around big mergers. One team was waiting for another team to check in. Basically, they didn't have any testing. So one of the things that they adopted was trunk-based development. The trunk-based development is at scale, then it's just doing smaller short-lived branches, which means that they actually don't have these maximum for a day or two, and make sure that the code that is checked into trunk or the master is actually still deployable to production. So that meant that the velocity was there because one team wasn't waiting a whole long time for another team to check in, and second, what was already in trunk was ready to go to production at any point in time. That increased velocity. Another thing that they did in their CI, because they didn't have any testing, was add a new chicken burned test, where they actually added their unit tests and other things as well into their pipeline, which we'll discuss a little bit later on later slides, and that detected if anything had happened to their algorithm.
Another element that FryMeUp has not considered is around how they're performing testing with each release. And with the example of the chicken getting burned, while they were getting ready to release their hot patch to fix the algorithm that's perfecting this this chicken frying formula, it was taking a really long time to release that patch, and that's because the regression testing was manual. It was taking about 2 weeks if done fully end to end, and it was resulting in high cost of every release and the release cycles being slow, resulting with slow velocity of improvement, slow velocity of deployments of effectively of our improved chicken frying solution. So they've adopted a regression testing using some of the AWS tools, such as the AWS code pipeline, which is effectively a way to stitch together jobs in a sequence, together with Amazon CloudWatch Synthetics, which is a way of monitoring which is a way of performing canary monitoring of a specific endpoint. With this solution in place, every time we're making a release, FryMeUp is able to run a canary test to test whether when the chicken is being fried, is it frying perfectly? Is the conditions of the chicken appropriate to effectively result with that best chicken in all of Australia that you can get from this air fryer that FryMeUp is promoting to have. And with the use of the step functions, they were able to orchestrate the execution flow that would prevent your CI/CD pipeline from deploying the code or deploying the change if there's a problem with the quality of our chicken.
So another issue that FryMeUp were having was they were deploying their new chicken recipes, and chickens were being burnt, and basically the algorithm wasn't being tested. They did find out that they were deploying and there were major issues. So they didn't have a good deployment at de-risking, a way to de-risk their deployments or to roll back if something had happened. So what they did is they automated the health checks, and they used a deployment process that allowed them to do blue-green deployments that allowed to do that verification before the new code was being could accept traffic from all the air fryers, or if there was a problem, to stop back and roll back. At AWS, there is a tool that automates all of this for serverless workloads such as the containers or lambdas, which are like the serverless functions through AWS Code Deploy.
Another thing that FryMeUp hasn't initially considered is how about having an ability to test new chicken recipes with small cohorts of people, perhaps a chicken frying beta testers user group or for any user that would like to sign up to these beta updates to get the latest releases of new chicken recipes. And also maintaining the making changes to the code meant that developers, when they wanted to release a new recipe, they couldn't actually deploy it until the new change was fully ready and fully working, couldn't be deployed to production. And this is where a concept of feature flags comes in really handy, because it allows the developers to do two things. It allows them to deploy new solutions without actually enabling them for the end users, and it allows them to control in the way in which it's released. Perhaps again releasing to that small group of beta testers, early adopters, or maybe performing A/B testings to check if the new recipe is more liked by the users, or perhaps results with with chicken being fried better, or having or resulting with higher reviews for the end users. And with Amazon CloudWatch, evidently, you can implement the feature flags, and you effectively implement all these good benefits to your air fryer really easily.
So one of the things that FryMeUp did do at the start was do infrastructure as code, and for all of the components that they were deploying, all those serverless functions, they wrote code that actually executed that on the cloud, which was great because that meant that they could automate their deployments a whole lot more faster. But they didn't start checking that infrastructure as users, as developers came in and modified it. And so you would find that sometimes the developer would do something like leave a database open to the world, or leave an S3 bucket with access to the world. That meant that competitors could come in and try to steal the recipes for this for the frying chicken, and it took a long time to rectify and to realize these these mistakes. So that was a real risk to the organization. One of the things that they implemented to prevent that was to do static code analysis, because it was great. Now they've got all the infrastructure as code. Now they can start analyzing that code and make sure that those rules that they wanted to implement and govern were set up from their pipeline. And they verified everything, and they make sure that never again was the recipes were open up into the internet.
Cool. Another thing to consider for FryMeUp is how they perform code scanning. And so far, they've been relying purely on doing periodical penetration testing to validate the security posture of their application. That was done on a quarterly basis. And while this was providing a lot of insight to making sure at a given point in time the application is secure, it was not performing that continuous security scanning. So when for example, the Log4j vulnerability has been discovered, FryMeUp had no way of detecting it. And bad actors realized the vulnerability existed and coordinated what we call a denial of chicken attack, effectively preventing users from making their chicken. By implementing solutions from AWS partners such as Snake or SonarQube, they were able to improve their security posture and shift the security to the left by effectively detecting those vulnerabilities before their code is released. And that has significantly improved the security posture and allowed these issues to be detected earlier, preventing from the potential denial of chicken attack happening and customers not being able to fry their chicken.
On another note, on the DOC attacks, the FryMeUp realized they didn't have basic edge security in the form. They had one thing. They had what we call application firewalls or security groups around their workloads, but they didn't really have a way to protect themselves once something started happening. And so what they did is they implemented a product that could help them with the layer 7 traffic, adding new rules. So they implemented a WAF, web application firewall, that allowed them to do those rules and make sure that traffic was blocked, or that there was that was detected as an anomaly, and so forth, using Shield Advanced. and therefore be able to block and stop those DOC attacks happening.
Observability is a big topic, and although FryMeUp considered a basic server-side monitoring for things such as number of requests and your backend service is receiving at the response time, what they were not doing is they were not monitoring the real experience of frying chicken and monitoring in a way that's end-to-end connected. And when there were local errors happening on the air fryer, such as perhaps a slow response time on the screen, or maybe the screen becoming unresponsive, maybe an exception coming up on the air fryer, these things were hard to capture and were not being monitored, and therefore the FryMeUp didn't have a correct monitoring posture that allowed them to monitor their application end to end using that holistic approach. And by implementing services called CloudWatch Synthetics, which is a way to perform canary monitoring of your application, as well as the CloudWatch Real User Monitoring, they were able to perform a real-time monitoring of the frying chicken process, and they were able to react to any air fryer burning chicken at any time. And for anyone that hasn't heard about the real user monitoring, it's effectively a way of injecting a little bit of a JavaScript to the client side that allows you to capture the client side metrics and send it to your monitoring server, and giving you insight into what's happening in the client browser, not just what's happening on the server side.
So one thing that FryMeUp realized is that frying chickens produce a lot of data, and they didn't have a good way to stitch together all of this data was generated in so many parts. There was data generated in the fryer. There was data generated in this in the CDN, in the APIs, in the serverless functions, in the database. What was going on when there was an error, how to correlate all of this information together. They didn't have a centralized tool to be able to query and to index and to analyze. And so what they did is that they did just that. They implemented a centralized monitoring platform, such as OpenSearch, that allowed to correlate and to aggregate all of this information so that they could actually start now stitching together all of these events and being able to quickly get to the point where they could identify issues or new insights on what was going on with their usage or with the general metrics that were being produced by the whole system.
Cool. And last but not least, when it comes to planning for disasters, FryMeUp realized that no matter what happens in Sydney and the regional area, they really need to make sure that customers need to be able to fry their chicken. And for that reason, they decided to implement a business continuity planning to plan for such events. So even if disaster strikes and Sydney region is knocked out and the Amazon data centers go down, there's a plan in place to bring the air fryers back online within the specified restore time objective, with a minimum data loss as per our recovery point objective. That allows the chicken frying, that allows the customer to continue frying their chicken no matter what's happening in the outside world.
Cool. So after implementing all of these things, this is what the architecture ended up with after they've gone through the DevOps journey. They were able to protect securely their edge infrastructure, receive real-time data from the air fryer to understand what was happening with the chicken. They were able to protect themselves from bad actors trying to steal their information and to do DOCs. They were aggregating all this data so that they could query it and understand it and be able to get insights. They were able to have de-risk their deployments using blue-green deployments. They were able to run synthetic testing and understand and do regression testing every time that they deployed and have confidence that what they were doing was right. And there's a lot of, I guess, little things that they did, and each one of those in itself, none of these are very complicated to implement, but putting it all together, the holistic solution, that's what actually gave them the advantage to those things that they wanted to achieve, that agility, that security that they wanted to achieve. So Air fryer is now perfecting the art of frying chicken every day, which is great. They've got continuous improvement on the algorithms, and they keep leading the Australian and New Zealand market in frying chicken, and they're looking towards the world. The CEO has sent a message now. She's very happy. I love what you've done. My chicken last night came out perfect. I loved our reduced lead time for changes, our change failure rate, and our increased deployment frequency. I also can't forget about the lower mean time to recovery and finding how long it takes to recover from a partial service interruption or total failure. What a CEO. So whatever you're working on, we recommend you, as a takeaway, that you implement some of these practices. And if you want to get started with AWS and you haven't, open an AWS account. There's lots of things that you can do in the free tier. We will distribute some of these links afterwards. We'll distribute this link afterwards, but this video is really good if you're just starting. It's called Back to Basics, just to see how that CI/CD pipeline can work. And there's also a workshop on CI/CD and containers, which is, I think, a great resource for people who just want to dive in a little bit deep and understand some of these concepts. For those who are already using AWS, we've put put here a video that goes into a little bit deeper on how to implement that blue-green deployment using containers, for example. And we recommend a lot this observability workshop. It goes through a lot of things that we've discussed today: X-ray, cloud synthetics, real user monitoring, and it's just got a ton of content that's really, really good. And that's about it. Thank you very much. There is one thing that we would ask. You know, we always want to improve, and there's a feedback link that it will be great if you give us feedback on how you found the presentation, and yeah, see how we did. But over to you all. Questions, comments?
Yeah, I've got a question. Just on your last diagram that you had up there, where you had all the different AWS components, yeah, that one there. That's all good, but then I noticed you were using Git up the top there to store your repos. Is there a reason why you wouldn't use Code Commit instead, which is an AWS offering?
Yeah. Actually, Seb and I work a lot on this space with different customers, and what we want to focus on is on the practices. Like, you know, the end goal, you know, what that CEO said, we want to be able to do what, you know, to increase those deployments, to reduce the time of change, to make sure that what they were deploying, you know, was good the first time around and so forth. I think that's our focus on the practices. So today we did mention a whole heap of AWS services, but we understand that, for example, a lot of developers and different businesses work on GitHub or GitLab and use different things for their pipeline. It's not about what we've talked about today. Doesn't have we've explained it with AWS services, but there's lots of components and they all can interplay. And one thing about AWS that you'll find is that a lot of our services, we do work with open source a lot. And so you'll see that different family of services in the family line that we have actually also use like open source technologies.
Okay, cool. All good. I've just got a quick question with the real-time user monitoring. With regards to that service offering, you mentioned that essentially it allows you to run JavaScript on a client machine from the server side. Is that correct?
Effectively, with the CloudWatch RAM real user monitoring, what you do is within your static content, that's your HTML and JavaScript. You include a little bit of a JavaScript snippet that the tool provides. And what your browser will effectively do is it will try to collect as much stats as it can, that is allowed to collect. It will make an outbound call to the CloudWatch endpoint to report on these statistics. So that's how you're able to effectively get some stats from the end user client, right? So this could be the console logs, any JavaScript errors. You can monitor things like the actual load time in the user browser, and you can kind of get a better understanding of that how the user has experienced opening that page or kind of interacting with this application, rather than just seeing, well, how did the request arrive to my backend and how did my backend handle it?
Okay, how would that work with cores?
It's a good question. Can you expand on that question?
So with cross object resource scripting, I know that. Okay, this is just kind of, I might be wrong. I haven't written a static website for a very long time. If you're specifying a different domain, that's not allowed in that list, the initial within the list. I can't remember where it, like, again, I haven't done this for a while. How would it overcome that? Does it inject itself within, like, or is that like a caveat that you just kind of have to go, hey, make sure you add this, this bit of code too, so it kind of gets around cores?
It's a good question. I'll be honest with you, I don't know the specific answer, but if I remember correctly with how cores work, your website will still make the request, but your server will not accept it. I might be wrong. I'll just stop answering in case I'm wrong.
I'm no cores expert as well, so
yeah, it works, and you can configure cores appropriately to make those requests to different domain, right? It's just a matter of configuration, and effectively, it's probably it is an element of the setup here.
I was going to say, you just I'm guessing you could just stick it in front of the API gateway.
Yeah. I think you did need to add the course of our origins to it, but yeah, I'd have to investigate as well what it is. Like, there's different ways that you can enable it, but all of this is all behind anyway the AWS infrastructure. But probably something that you need to configure.
Yeah, that's really cool. Yeah, I was gonna say I was trying to think of some really terrible dad jokes, but I only got one. So, which was that some may say they were frying the system when there was a chicken denial of service attack, and so.
Yeah, that's right. We've got a lot of cheesy chicken jokes here.
Yeah,
canary monitoring.
I was going to say, how did KFC respond to this? Like,
they're interested.
Just save stuff. Like, okay. Does anyone else have any other questions? Just quickly, like, I'm opening it up to chat as well. Feel free to throw questions in chat, and I'll relay them. Thank you. It was really, really good. I'm actually going to try and since I've got a record of it, we're going to send it to the guys at work, because it's kind of trying to show the vision of, at least, understanding the DevOps practices around, just like trying to implement basic unit tests and get things that side of things going. And then, that's really, really good. Thank you so much.
Yeah, I was going to say, and one of the things that we found as we talk about this with customers is it's pretty common that people focus on the build side, but it's in the run side that they find the agility, and so that's always a good way to start that conversation, and to say, okay, if we want to be like, what do we want to do? We want to deploy once every 6 months, every 1 month, every so often, and then work backwards from that problem. What do you need to tweak inside your processes to get to that.
I was going to say, like, that's one of the things that within our organization we struggle with is that, like regression testing that takes weeks.
Yeah, exactly right. Yeah,
it's one of those
it's
things
all
that,
manual, and you have to do
yeah.
it again and again and again. But if you just got one person to record what they were doing when they were doing it that time, then all of a sudden that's a test that's committed that you can just run in your pipeline.
I think, and the other thing is as well is this, there's a lot of like for me, it's just like, okay, some of these tests, they don't even need to be regression tests. They can just kind of, you can run an integration test to be able to kind of do the same thing without having to actually, have user input. So, yeah, it's just one of these things. Yeah, there's the struggles. But anyway, I think, I don't actually. There's no questions in chat. So like I said, I'll just leave it up there if you've got any questions in chat. Is there any way that if anyone has any further questions that they can reach you guys?
Great question. We should have added this here. We do have our emails. So add them here. Should have had this here. But that's effectively our email addresses. So yeah, certainly give those links a try. So we will share. This is recorded, so you can grab those links from there. And we can share the presentation as well with you, Michael, if you would like us to, like PDFs. Give those links definitely a try. But yeah, also if you're building something on AWS and need some solution architect guidance, feel free to reach out. You can reach out to us, and the chances are your company has got an account team assigned already. If you don't know who that is, we can help, or you can just shoot a generic email to AWS to find who that person is. There will be a solution architect that can help you as well. But yeah, reach out to us as well if you would like to in the first place.
Yep, perfect. I could send you. I'll be putting this up on YouTube either today or tomorrow, probably tomorrow afternoon. So yeah, I can just send you guys the links, and then we can send each other links or whatever. That's fine.
Awesome.
Yep, and then and I can, and then cool. All right, I don't think there's anything else. Does anyone else have any other questions, comments, queries? See anybody? All right, I think we might just leave it there. Anyway, thank you so much, Carlos and Seb. That was really, really good. I definitely got a lot out of it. It's always kind of good to see what's happening out there, and kind of validate your own what you kind of validate your own thinking, and then look at what other options are out there. So thank you everyone, and like I said, check it. Make sure you leave feedback. And also, please jump on if you're not on Slack. Let me know. I'll get you on Slack, and we can kind of get feedback for the user group. Alrighty. Anyway, thank you, everybody.
Thanks
See
all.
you guys.
Cheers.
Bye-bye.
Bye.
Thanks, guys.